Hi friends, this is Sri Ramulu. So I have come with a new topic that is the energy stored in capacitor. Okay, how does it stores the energy? Energy storing means the plates of capacitor must store the large number of charges. Large number of charges. That is a capacitor energy stored. Okay friends, so I have given the definition in the last video. Now the energy of a charged capacitor is the amount of work done in charging it. Energy of capacitor means making keeping charges on its surface. How much charges you are keeping, that much of energy will increase. Next, a charged capacitor stores an electric potential energy in it. So energy, which energy is that? Is a potential energy. So capacitor can store in the form of potential energy. Now consider a capacitor of capacitance C and carrying a charge Q at any instant. Let the potential difference between the plates is V, then V is equal to Q by C. Okay, so I have stored certain charges on these two plates. Now what I am doing, I want to keep extra charges. I kept large amount of charges on these two plates with a positive and negative. If you want to keep a small amount of charges, that is denoted by dq. Dq is a small amount of charges against. Here you have to, this side you have to keep plus charges. So means again one more plus, few more plus charges you have to bring. So plus will repel. Even though what you have to do, you have to work done against its repulsion force. So how much charges you are keeping? Small amount of charges. So that is the dq. Okay. Then how much work is done? That work done is given here. So when the charges are small, then work is also very small. So that is why there is a relation between work and potential energy in charge. What is that? Already it is a definition for the potential. The potential is what? Work by charge. So from this only, work is equals to bring this side charge into potential. The same thing is written here. Small charges can make the small work done. Okay, na? So dw is equals to V value is from here. So substituted Q by C. Now if we integrate, then we get total charges. So maximum charge is denoted by Q naught. Minimum charges means already we know that is 0. No charges more. Integrating above equation from 0 to maximum charge Q naught, then we get total work. What we get? So this is. Okay. So work done. Q by C. dq. So here 1 by C is a constant. Q is a integrable. Okay. Integration Q dq can be written as Q square by 2. Like a integration x dx x square by 2 in the same manner. Okay, it is like this. Now the energy stored by a capacitor, by charged capacitor, is how much? It is, this work done may be stored in the form of energy. That energy is a potential energy. Potential energy is denoted by U. So U is equals to Q square by 2C. Okay, na? And already we know from the formula of a capacitor, C is equals to what? Q by V. And from this, Q is equals to CV. So that means in the place of Q, write CV. So then CV whole square. So among the CV whole square means C square also present. So C square, once C gets cancelled, so only one C will be there. So CV square. Half CV square is the potential energy of a parallel plate capacitor. Now, for parallel plate capacitor of area A and plate separation D, means if two plates are separated at a distance D, that is the meaning of D, then the capacitance C is given by, already we have derived this equation. So right, with a T we have derived epsilon naught into A by T. Okay, and now V is equals to ED. It is already we know potential is equals to electric field into distance. This is the relation between potential energy and electric field. Electric potential and electric field. Substituting C and V. So that means these two equation. In what equation? In the above equation. In the equation 3. So in the place of C, in the place of V. Then we get it is like this. In the place of C is this one, in the place of V it is already V square is this, so that is why ed square. And now ed square can be written as e square d square. Already downside d is there, 1 d gets cancelled, 1 d will be there. Okay na? And this a and d are written one side, so that means area into distance gives the volume. Area into distance gives the volume. So ad is a volume. So energy stored, energy, therefore energy per unit volume means bring this ad this side, then u by ad is what, half epsilon naught c square. It is what, energy per unit volume. So energy stored per unit volume is what, half epsilon naught e square. So this is friend energy stored in the capacitor. Okay, thank you friends.